I also want to draw your attention to some other commands in R that we haven't yet discussed but are useful, especially if you continue to use R. So I have some small examples here. There's a function called by. By will do some function to some vector, but after splitting it into groups. So for example, if I want to take the mean of sepal length for each species, then the first argument is the vector of the values I want to take the mean of. The second argument is the grouping variable, the factor that puts them into groups, and the third variable is what I want to do to each of these groups. Take the mean, take the variance, take the sum. So if I run this command, now I've got the mean sepal length for each of the 3 species in the iris data set. This command is especially helpful, this command called apply. What does apply do? Apply takes a matrix and it does the same function, does the same thing to either all the rows or all the columns. How do you specify this? Well, let me start with a data set. So I'm taking the data set iris, and this is a subset of the data set iris because I'm going to take the mean and I want to leave off the species column because I can't take the mean of a word. So this data set consists of the first 4 columns of the iris data set. That's what I'm going to do something to. This 2 right here says I'm going to do the same thing to all the columns in this data set. If I had a 1 here, I would do the same thing to all the rows. What is it that I'm going to do to all the columns? I'm going to take the mean. So if I run this line, now I have the mean of each column in the data set that I specified. The which command gives you back indices. So you know that iris $species is the vector of all the species in the iris data set, and iris $species equals Virginica is a vector of trues and falses corresponding to whether each of those species happens to be Virginica. Which iris species equals Virginica tells you the row numbers of the data points where the species is equal to Virginica, which can be helpful if you'd like to do something to those particular rows. Note that the notation we use for the regression is tilde. We can also use to make box plots. So you know that in order to make multiple box plots in the same picture, I could write something like this. I can write box plot maybe the numbers 1 to 10, and give me another box plot of the numbers from 2 to 20. And if I do that, I get those 2 box plots next to each other. Another way to get box plots next to each other is to say, give me the box plot of this variable grouped by this variable. So again, if you have a grouping variable, you can use this tilde. And the result of this is going to be the 3 species, each with their sepal lengths shown here, and the labels will automatically be equal to the species values. There's also something called an if statement, which can be very helpful. And it's exactly what you'd think. If this conditional here is true, do this thing here. So 6 is not greater than 7, right? This is not true. So if R gets to this, it's just going to skip over this and continue on. But if whatever is in these parentheses is true, R will do the thing that's in here. Much more helpful is something called an if-else statement. Let me show you a little bit how that works. The first argument to an if-else statement is a conditional, so something like 6 greater than 7. The second argument is what we should output if that statement is true, and the next thing is what we should output if the statement is false. So this says, test whether 6 is greater than 7. If so, spit out 1. If not, spit out 0. So what are we going to get here? Of course, we're going to get a 0. What's interesting about this command, though, is that any of these arguments is allowed to be a vector. So suppose my conditional looks like this. Here's the true-false question. Is each of these numbers greater than 7? So what I've highlighted here is going to be equal to a vector that goes like this. False, 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 true. So what is R going to do? It's going to give me a 0 for each time it's false and a 1 for each time it's true. But I could also make these things equal to vectors. So maybe this is the numbers from 1 to 5, and this is the numbers from 16 to 20. What's going to happen now, each time this vector is equal to true, it'll give me the corresponding value from this vector of things to do when the statement is true. Each time this conditional is false, it'll give me the corresponding value from this vector of things to do when false. So remember the vector was false, 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 true, so it gave me 16, 17, 18, 19, 5. Why is this helpful? Because all of a sudden, you can do things like if else the species is equal to Virginica, I'm going to make my point red, otherwise I'm going to make my point blue. Now I have a whole lot of reds and blues. This is a shortcut for the kind of thing we've already done, and I could use this vector I just spit out as the input for the colors in a particular plot. There's a lot of other uses for the if-else command. It tends to be very helpful.